Okay, so in DSMA 7 all the way through DSMA 10, we're going to do one of the funnest things in algebra, factoring. So you are actually doing algebra when you play some of these video games like Mario Brothers or what's the other one? Angry Birds. I don't know how to play any of them, but you have to figure it out in order to get that parabola, which is now reflected on the x-axis, to land where you want it to. All right, let's do some factoring. All right, so you're going to hear greatest common factor a lot in these next few sections. We abbreviate it as GCF. Whenever we factor, we want to look for the greatest common factor first, because if we can pull anything out of the problem, it's just going to make our work a lot easier. So what we're going to do is we're going to look for numbers in common. We want the largest number that's in common to all of the terms. And then we're also going to look at the variables. So let's look at this one. We have 30x squared plus 25x. So notice with the 30 and the 25, those both have a 5 in common, but that's it, right? And so what we're going to be able to do, we call it pulling the greatest common factor out of the polynomial. We're going to be able to pull a 5 out here to the front. All right, so now we want to look at the x's. So we have an x squared, so we have x times x over here, right? X times x. And over here, we just have the 1x. So we can't, it's a little bit of a misnomer here. We can't pull the greatest amount of x's out because that wouldn't work on the second term. I can't pull 2 x's out of 1x, but I can pull an x out of both of those. Okay, so I'm going to also pull an x to the front. Okay, so what this really means when we are pulling that to the front, now we're not always going to write this, but what it means is that we're going to divide that. We're going to divide the number and the variable that's in common to both of these terms, and that's going to go on the bottom. Right, so we're going to pull the 5x out to the front. What that means is we have to divide each of those terms, or however many terms we have, by that greatest common factor. So out front is your greatest common factor. Okay, so once we do that, we have the 5x left out front. We have to keep that out front. You can't just drop it. Now we're going to use some of our exponent rules. So we have 30 divided by 5. That gives us 6. X squared divided by x is going to just give us x. In the next one, we've got 25 divided by 5. That gives us 5. And then finally, x over x is just 1. Right, so this is actually my answer, but I'm going to come over here in the corner and just check my work real quick. So if I check, what I'm going to do is multiply this. Whoops, I didn't mean to put that there. Multiply this back in, right? So I have 5x times 6x. That would give me 30x squared. And then I have 5x times 5, and that would give me 25x. And so I'm back to my original problem. All right, so that's just a check. But what I really want here is this 5x that has been pulled out. The greatest common factor has been pulled out. And you can see now I have a much smaller polynomial to deal with on the inside. All right, let's try another one. Okay, so this problem says factor out the greatest common factor. We are going to look at the numbers first. If we look at 3 and 18, they have a 3 in common, but that's as large as I can go with that one. And then again, I have the x squared and the x. So I can't pull 2 x's out because I can't pull 2 x's out of this second term, but I can pull 1 out of each of those. Okay, so now what's going to happen? Now, a lot of you are probably doing this in your head. You don't have to write all this. I just want you to see what's going on. We're going to divide both of these by 3x. But when we put our answer in, we have to have the 3x out front, and then 3 over 3 is 1, x squared over x just gives me x, and then I have a subtraction. 18 over 3 is 6, x over x is 1. And so I have now factored out the greatest common factor. Pretty soon we'll be able to do some more factoring inside the parentheses, but let's come over here and check our work real quick. All right, so we're going to use distributive property. We're going to multiply 3x times x. That gives us 3x squared. And then 3 times negative 6 gives us, 3x times negative 6 would give us negative 18x. And so we're back to where we started. All right, so we have a little bigger polynomial here. We're gonna factor out the greatest common factor. So when you first look across these numbers, you see 9, 18, 27. It's probably pretty easy to see that a 3 would go into all of those, but that's not the greatest common factor. And so you would have not simplified completely, it's called. So actually a 9 goes into each of those numbers, 9, 18, and 27. So we're going to pull a 9 out to the front. Now let's look at these variables. I have 4x's here, 3x's here, and 2x's here, like that, right? They're all multiplied together. And so there's no way I can pull 4 from all of them because I only have 3 here in the middle and I only have 2 in them at the end. But I can pull 2 of them from each of them. So I'm going to actually be able to pull an x squared. Okay, so when we're looking at variables, we're actually going to grab the smallest exponent. And then when they get really big like this, that's when this whole dividing works to help you just keep track of what's going on. So each of these we are going to divide by 9x squared. So the 9x squared is going to stay out front. On the first one, 9 over 9 is 1. X to the fourth over x squared gives me x squared. On the second one, 18 divided by 9 is 2. X to the third power divided by x squared leaves me with just 1x. And then finally, 27 divided by 9 is 3. X squared over x squared is 1. And so I am done. And then you could, of course, check your work. You could either just eyeball it using distributive property, or you could go ahead and write it out and check your work. That helps just in case you're not confident about your exponents. All right, this is called factoring by grouping. We're going to do a little more, I think, in the next part of this video. I know it looks really weird, but remember this is x times a polynomial, right? X times a polynomial. And then this is negative 19 times a polynomial. I can't seem to get my little dot to work. So what's in common to both of those is this whole polynomial, right? Looks crazy, but that's what's in common to both. And so we're actually going to pull that binomial to the front, right? We're only going to pull it the one time, just like we did with all those others. We only pulled a 3 one time out of all of them, or we pulled a 9 out of all of them. So in this one, we're pulling an x plus 19 out of each term, pulling that to the front, and then what's left is we have an x left here, and we have a minus 19 left here, and so we're now going to write what's left. So that is going to come here. We're going to do another one in just a minute, and this one's going to come right here. Okay, so we pulled what was in common to both. That was the x plus 19. And then we grabbed what was left after we pulled that out. What was left was the x minus 19. And that is actually our answer. Now the problem is if we multiply this back, it might not look like it's in the same form, but what would happen is you'd have x plus 19 times the x, that would give you the first term, and then x plus 19 times the negative 19, and that would give you the second term. All right, let's try another one. All right, so again, we're going to factor out the greatest common factor, but the greatest common factor, there's nothing in common between the x squared and the 17, but both of the terms are multiplied by this x minus 7, because remember, I've got multiplication here. If you don't see any other sign next to the parentheses, then you know that it's multiplication. So we're going to pull the x minus 7 out to the front, and then we're going to grab what's left. So we're going to grab the x squared plus 17. And that's it. That's our answer. If we checked our work, we would take the x minus 7 in front times the x squared. That would give us that first term. And then we would take the x minus 7 out front times the 17. Okay. Okay, now we're going to really start factoring. So I'm given this polynomial. I have x squared plus 9x plus 14. What we're doing is the opposite of multiplication. I'll show you that when we check our work. Okay, so what we're going to do is we want, because we're doing the opposite of FOIL, we want to find two numbers that if we add them together, we get the 9 in the middle. If we multiply them together, we get 14. Okay, so if we, two numbers that when we add them together, we get 9, and when we multiply them together, we get 14. So one way to look at this is to see all the different ways that we could get 14. So let's come down here. We could take 1 times 14. We could take 2 times 7. I think that's it. Okay, so what we're going to do is 1 times 14 is great because when we multiply it together, we get 14. But when we add these two numbers together, we get 15. So that's not going to work. For 2 times 7, well, 2 times 7 gives me 14, so that's good. And then 2 plus 7 gives me 9. Yay! All right, so those are my two numbers that I need. So I'm going to come up here. I know that because I'm working opposite of multiplication, I know that I'm going to have two binomials. In the front, I would need x and x, right? Because x times x would get me the x squared in the first term. And now I know, based on this analysis we did over here on the left, that I would need plus 2 and then plus 7. Now, order does not matter. The signs matter when we get to signs, but the order does not matter. So you can write x plus 7 and then x plus 2 because order doesn't matter in multiplication. All right, so that's actually the answer, but let me show you where that answer came from. Let's check our work. So we're going to FOIL. Remember FOIL? I know, we've all slept since then, but all right. So FOIL is first, outer, inner, last. So if I take the first two terms, that would be x times x, so that would give me x squared. If I take the outer terms, I would have x times 7. So 7x. If I take the inner terms, I have 2x, and then 2 times 7 would give me 14. Now I'm not finished because my middle terms are like terms, and so I would get x squared plus 9x plus 14, and sure enough, that was the original problem. So basically what we're doing is the backwards of multiplying. We're not exactly dividing. We'll get to that, but we're doing what we call factoring. And so that's why this works over here with the plus and the multiply. After you do a ton, you'll probably just see it. For the most part, we don't give you numbers so big that you wouldn't be able to see what's going on. All right, let's try another one. All right, so this one's a little bigger. It's 2x squared plus 24x plus 54. Now, I didn't say it in the last problem because we were just getting used to these trinomials. Trinomial just means there's 3 terms, but we always want to check and see if we can pull a greatest common factor out because that just makes it easier. So in this case, our numbers are going to get a lot smaller. We're not going to have to deal with the 54 and the 24 if we take a 2 out of there, because they are all even, and so they're all divisible by 2. So let's make this a little bit smaller here to work with. Right, I'm going to divide all of the numbers by 2. There wasn't an extra x in the last term, so I couldn't pull an x out. Now, it's really important that you leave that 2 out front. You can't just drop the 2. So I'm just going to leave it there. All right, so we're going to do the same thing. We want 2 numbers that when we add them together, we get the 12 in the middle. And when we multiply them, we get the 27 on the end. All right, so let's look at 27. So we have a couple different ways we could multiply this. We could take 1 times 27. 2 doesn't go into 27. 3 does. We could do 3 times 9. I think that's it. I don't think any. 4 doesn't go in. 5 doesn't go in. 6 doesn't go in. Yeah, that's it. Okay, so we need 2 numbers that when we multiply them, we get 27. Well, both sets of these multiply and give us 27, but when we add them, we want to get 12. So that would be the 3 and the 9. So if we multiply 3 times 9, we get 27. If we add 3 plus 9, we get 12. Okay, so awesome. We have a 2 out front, and then we have x plus 3 and x plus 9. Again, the order does not matter. It's not wrong to say x plus 9 and then x plus 3. Okay, and then you could check your work. Same idea. Let's go ahead and do that real quick. So if we check, we're going to FOIL, but we have that 2 out front. So when we FOIL, we get x squared plus 9x plus 3x plus 27. We're going to combine like terms in the middle. And then we're going to distribute the 2 to get back to the original problem. So it's good to check your work, especially check the middle term, because you want to make sure when we start doing signs that we have the correct sign. Okay, let's go to part 2.